Hello students, my name is Kulvinder Singh, Assistant Professor of Geography, Pandit Chiranjit Lal Sharma, Government College, Karnal, Haryana. Today we will be discussing interior of the earth, evidences of the interior of the earth and some modern views related to the interior of the earth. This topic is there in your geography paper of the BA second semester under Kurukshetra University. This is one of the lectures to be live telecasted by EduSet, Haryana. Humankind has always been a religious and spiritual being since the establishment of empires and civilizations. Our religiosity had strong command over our understanding of earth and universe because we had little understanding of scientific phenomenon due to lack of technology which restricted our observation to just our surroundings. With the evolution of science and technology, a counter view has emerged against the theological understanding of formation of earth and universe. However, our ability to observe universe is minuscule in comparison to the size of the universe. Further, we cannot directly observe the universe and have to depend on the deductions emanating from our own understanding of physical phenomena on Earth's surface. In this quest to understand our origin and of this universe, we must understand the interior of the earth because it will help support our endeavor to know if it was God or random phenomena in empty space which led to things as we see it today. In today's lecture, we will be aiming to fulfill three major objectives. First, study the direct and indirect evidences of the interior of the earth. Second, learn the components, density, thickness, and physical state of different layers of the earth. Third, discuss some modern views on the interior of the earth. There are two types of evidences which provide us information regarding Earth's interior, that is, direct and indirect evidences. Indirect evidences include the evidences which are deduced from our understanding of physical phenomena and is not directly visible, such as temperature, pressure, density, seismic waves, radioactive decay, meteors, gravitational anomaly, and magnetic field. Whereas the direct evidences are directly observable, such as volcanic eruption, rocks from mines, and bore wells. The relationship between temperature, pressure, and density in the Earth's interior also provide valuable information. The pressure and temperature are positively related. Increasing pressure with depth leads to greater temperature and vice versa. The rate of increase of temperature initially increases from 12 degrees Celsius per kilometer to 20 degrees Celsius per kilometer, but drops to 10 degrees Celsius per kilometer after the depth of 400 kilometer. With this rate of temperature increase, the temperature at the core of the earth reaches around 6000 degrees Celsius. By this rationale, the core of the earth should be liquid, but it is not. The inner core is in solid state because the pressure increases in closed spaces leads to increase in density. The density of rocks increases from 2.7 grams per cubic centimeter to 11 grams per cubic centimeter approximately from crust to core. Due to such high density, Earth's inner core stays in solid state. The waves produced by movement of Earth are called seismic waves. These waves propagate through the point of origin in all directions. These waves are key to understanding Earth's interior. Seismologists study the nature of these waves. There are three types of seismic waves: primary waves, secondary waves, and surface waves. P waves pass through both liquid and solid mediums and propagate at a speed of 6 to 7.2 kilometers per second. However, their speed declines in liquid mediums. These are also known as compressional waves because it moves the matter to and fro through which they pass. It can be seen in figure 1. S waves. S waves can only travel through solid mediums. If S waves suddenly disappear at a certain depth, it can be argued that a liquid layer exists at that depth. These waves travel at a speed between 3.4 to 7.2 kilometers per second depending upon density of medium. These waves move the matter at a right angle to the direction of propagation. The rock particles move up and down as shown in figure 2. Surface waves travel only at the surface layer of Earth. They are of two types: love waves and Rayleigh waves. Love waves produce horizontal motion in material through which they travel as shown in figure 3. Rayleigh waves are also confined to crust but moves the material both vertically and horizontally, leading to a rotatory motion. These waves cause maximum devastation during earthquakes. It is the P and S waves, also called body waves, which provide us information about Earth's interior. As shown in this figure, S waves totally disappear and are deflected at the boundary of outer core, whereas P waves pass through core but are deflected both at the mantle outer core boundary and outer core inner core boundary. It points that the physical state of outer core and inner core is different. It is due to this nature of P and S waves that at a angular distance of 105 to 140 from epicenter of earthquake, no direct seismic waves are felt. This zone is called P wave shadow zone. Radioactive decay. There are radioactive elements in Earth's interior such as uranium, thorium, radium, plutonium, etc. These radioactive elements decay due to presence of humongous pressure and temperature in the interior of the earth. Due to their decay, these elements release great amount of heat. It is believed that around half of Earth's heat is contributed by these radioactive elements. Combined with the pressure from superincumbent load of rocks, it can cause melting of rocks. Magnetic field. Magnetic field around Earth protects it from electromagnetic storms emanating from outer space. Such a strong magnetic field can only be formed if there is a liquid metallic layer between two solid layers. Further, changes in shape and direction of magnetic field points towards movement of liquid metallic materials inside Earth. From this, it is deduced that an intermediate layer in Earth is liquid. Volcanic eruption. Volcanoes pour hot melted rocks on Earth's surface from deep interiors of the Earth. The origin of this lava is believed to be in upper mantle, which is believed to be in semi-molten state. Mining and bore wells. The evidence from mining and the earth surface boring the earth's surface shows that there is increase in the density of rocks and increase in temperature and pressure as we dig deeper. Hence it is likely that interior of the earth is very dense and hot. From the study of these evidences, we can conclude that density of rocks in earth increases with depth. Temperature of the rocks in the earth increases with depth. P and S waves change speed and gets deflected as they cross boundaries of different layers of earth. It points towards varying density and state of matter as we pass from one layer to different layer. One layer under crust is certainly liquid state as S waves cannot pass through that layer. The innermost part of the earth is formed of dense metallic elements. Based on the evidences of Earth's interior, the scientists have formed a largely uniform opinion about interiors of the Earth, which is as follows. Earth's interior has three major layers having different composition, density and state that are crust, mantle and core. Crust. Crust extends to about 5 to 30 kilometers in case of oceanic crust and 50 to 100 kilometers in case of continental crust. It averages around 30 kilometers for whole of the earth. The boundary between crust and its lower layer mantle is called Mohrvik discontinuity because speed of the waves suddenly increase at this depth. The density of crust is around 2.7 grams per cubic centimeter. The temperature of the crust increases with depth, reaching about 200 degrees Celsius to 400 degrees Celsius at the boundary with the underlying mantle. The crust is formed largely of silica and aluminium. Oxygen forms the largest single component of this layer. Mantle. Mantle extends from base of the crust to about 2900 kilometers deep inside the earth. The density of this layer is approximately 2.9 to 3.3 grams per cubic centimeter. Temperature of this layer ranges from around 200 degrees Celsius from Mohrvik discontinuity to 4000 degrees Celsius at about depth of 2900 kilometers where it meets outer core. This layer is largely formed of silica and magnesium. 45% of the matter in the mantle is formed of oxygen. It is noteworthy that mantle contains more water than all of the oceans on the earth's surface. The water in the mantle is primarily in form of hydroxide ions. Modern views. Previously, it was conceived that mantle has two major layers. One is upper mantle, the other is lower mantle. But according to the modern views, mantle has four major layers. The topmost layer is called upper mantle. Upper mantle contains two primary layers. One is lithospheric mantle, that is from 30 to 100 kilometers deep inside the earth. Lithospheric mantle is in solid state and is attached to the crust. The layer below lithospheric mantle is called asthenosphere. Asthenosphere extends from 100 kilometers to 410 kilometers deep. The asthenosphere is in semi-molten state because the increasing temperature with depth leads to melting of rocks. It is the asthenosphere which provides lava for volcanic eruptions. The third zone is called transition zone. It is it extends from a depth of 410 kilometers to 660 kilometers. It acts as a zone between the upper mantle and lower mantle. It is in solid states and it is believed by the scientists that the transition zone prevents the parts of lithospheres from sinking further into the lower mantle. The fourth layer is called lower mantle. Lower mantle extends from 660 kilometers to 2900 kilometers. Lower mantle is in completely solid state. It is so because the ability of pressure to keep the material of lower mantle in solid state exceeds the ability of the temperature to melt those rocks at that depth. The boundary between mantle and core is called Wiechert-Gutenberg discontinuity. At this depth, the speed of P waves suddenly increase. Core. Core extends from 2900 kilometers to the center of the earth, that is 6378 kilometers. The core has the density of around 9.9 grams per cubic centimeter to 14.2 grams per cubic centimeter. Temperature at the center of the core reaches around 6000 degrees Celsius. The core is primarily formed of nickel and ferrous. It is an interesting fact that core has greater amount of sulfur present in it than the rest of the earth. The core consists of two layers, outer core and inner core. Outer core extends from 2900 kilometers to 5100 kilometers and inner core extends from 5100 kilometers to 6378 kilometers. Since P waves are deflected again while passing through the core, it is concluded that there are two different layers in the core. One is liquid and the another is solid. The outer core is in liquid state. The outer core is in liquid state because the ability of the pressure to keep the material of the outer core in solid state is lesser than the ability of the temperature at such a depth to melt the material of the outer core. This means temperature at the outer core is so great that even the pressure at the outer core is unable to keep its particles in the solid state. Modern views on core. As we all know that Earth forms a magnetic field around itself. To produce a magnetic field, the Earth should work like a dynamo, which necessitates that there must be a metallic liquid layer in between core and the upper layers. The Swarm satellite constellation of the European Space Agency has observed that the outer core's liquid material moves in wave-like pattern towards the west, similar to the jet stream in the upper atmosphere. This movement in the liquid material of the outer core has been observed by studying the changes in the magnetic field of the earth. There are some new evidences about the inner core also. The KTH Institute in Sweden observed that the inner core is in a metallic crystalline state, unlike the solid state of nickel and ferrous on the surface. The core manages to stay in solid state due to reshuffling of iron crystals. As soon as the iron crystal is liquefied, it slides away and is replaced by solid iron crystal, just like shuffling of deck of cards. This continuous replacement of liquid iron crystals by solid iron crystals helps the core to stay in the solid state. From this discussion, it can be concluded that the interior of the earth has not been observed directly, but the deductions from our observation of seismic waves, laws of physics, and changes in magnetic field enables us to understand the interior of the earth. The progress in modern technology has furthered our knowledge of our planet Earth to new heights. However, human race should not be content with our present understanding of Earth because it is still incomplete and needs betterment. Students, if you have carefully listened to this lecture, you will be able to answer the following questions. Each questions have four alternative answers. There is only one correct answer. Choose any one of those four options. Who study the waves produced by the earthquakes? Radiologist, wave scientist, seismologist, physiologist. The molecules in P waves moves in which direction? Up and down, to and fro, diagonally, none of the above. What is the boundary between crust and mantle called? Mohovich discontinuity, Rapiti discontinuity, Gutenberg discontinuity, Conrad discontinuity. What is the boundary between mantle and core called? Mohovich discontinuity, Rapiti discontinuity, Gutenberg discontinuity, Conrad discontinuity. What is the depth of Gutenberg discontinuity? 2600 kilometers, 2700 kilometers, 2800 kilometers, 2900 kilometers. Which layer contains the highest amount of sulfur? Sulfur. Crust, mantle, asthenosphere, core. Which layer contains more water than the surface water in hydroxide ion form? Crust, mantle, asthenosphere, core. Which wave passed through both liquid and solid materials, P wave, S wave, love waves, Rayleigh waves. P wave shadow zone extends at an angular distance of 90 to 100 degrees, 80 to 94 degree, 100 to 110 degree, 105 to 140 degree. The semi-molten layer of Earth is called Morwich discontinuity, lower crust, asthenosphere, outer core. The increase in pressure leads to lower temperature, higher temperature, lower density, constant density. Why is inner core in solid state? Due to magnetic field, due to very high pressure, due to low temperature, due to chemicals. What are the largest components of metal? Silica and iron, silica and magnesium, nickel and ferrous, silica and aluminum. What are the largest components of crust? Silica and iron, silica and magnesium, nickel and ferrous, silica and aluminum. What are the largest components of core? Silica and iron, silica and magnesium, nickel and ferrous, silica and aluminum. Swarm satellite constellation belongs to which space agency? European Space Agency, ISRO, NASA, Russian Space Agency. What is the radius of Earth? 5368, 4356, 6378, 7778. Approximate temperature of core of Earth is 4000 degree, 5000 degree, 6000 degree and 7000 degrees Celsius. Which is not a radioactive element? Uranium, nickel, thorium, plutonium. The physical state of iron in the core of Earth is unknown, crystalline, liquid, plasma. I hope this lecture was useful for you. Thank you and best wishes.